So now we're looking at the same asset inside of Houdini after the process has been run on it. Here we can see the input, just as it looks inside of Unreal, and here is the output as the tool sees it in Houdini. We're missing the textures and materials because we've actually assigned those via attributes on the tool itself so that they'll be understood by Unreal. And inside of Houdini, we don't have the textures to assign anyway. If we have a little look back through the settings, you can see that we've got the same menu that we had inside of Unreal. We have the fracture menu, the breaking menu, we have this optional meld step, chipping, deposition, and the final output. Finally, we have the material and the other attributes we want to set for Unreal, and we can modify the final output or some of the quality settings here with this size parameter. We probably won't be touching this. If we open up the quick Ruinify now and allow editing of contents, you can see we have a relatively simple Houdini graph here. There's not too many steps. And if we just work it down from top to bottom, we'll be able to see what each step is responsible for. If we go up to the top of the graph, then you can see that we have our input. We convert it into a volume or a VDB. We subtract the second input from that volume if it exists, and then we convert back to meshes. This is to get a kind of beveling sort of effect happening, and also to make sure that the geometry is even for the next processing step. If we move down, you can see that we have two possible threads here. If we go down to the bottom of the left thread, then it just takes us to a switch. And that's because all of the features of this tool can operate independently, and we just are able to turn on the features that we want. Now, if we move back up to the top and start to follow down the right thread, you can see that we bump into this compile block. Compile blocks in Houdini allow us to run sort of operations over lots of pieces faster in a multi-threaded way, and they also reduce the amount of memory that's required in certain circumstances. We'll be setting up a similar network to this, and the responsibility of this network is to create the fractures that we can see here. So they're not immediately apparent because even though we are introducing those fractures, we're not actually sort of separating out the bits of geometry from these cracks. That's what happens during the following polyreduce step. Polyreduce here is just a little hack I found that works quite nicely with fracturing in order to sort of break up those fractured edges and introduce some nice planes. After the polyreduce, we have the option to use this kind of explosion, this exploded view node, which just moves all of these pieces apart from each other slightly and can give a slightly more sort of natural, organic look. If we move down further, we can see that we have the edge wear process running. And this process actually, it might have been a little hard to see there. But if I go back to smooth shaded and go back to the previous step and then back here, it might still be a little bit hard to see. So we're actually going to go to flat shading, and now hopefully it'll become more apparent. But you can see that we go from quite a faceted look after the polyreduce to a more detailed kind of breakup of the edges, which is giving a more visually pleasing end result and looks, again, more natural and more organic and like a real object that's been worked on over time. We get these nice little details here and scratches and other sorts of features being introduced. So we'll have a look at how we set up this custom edgeware node too. And if we keep on going down, the final step before the export is to do this kind of deposition or this smoothing out and inflation on upwards facing normals. So the idea here is that the ruins have been around for a really, really, really long time, enough that organic matter and mulch and sediment and maybe moss has had time to accumulate on all of these due to the effects of gravity and wind and rain and so forth. So this is quite simple. We just convert our mesh back to a volume once more, and we also at the same time create a lot of scatter points on the upwards facing planes. We add a little bit of noise, and then we use VDB from particles to create a volume representing these sort of blobby, mulchy areas. We smooth that out, and then we use VDB combine to combine those two results, giving us a pretty visually pleasing, at least I think, end result, with this kind of soft, almost snow-like matter or dust or sand or mulch that sits on top of the harder, more architectural elements. Finally, we convert back to polygons. We do a polyreduce operation, and we're pretty much ready to call it there. The only other thing we need to do is make sure that we set up some vertex colors so that we know where we need to texture as moss versus where we need to texture as stone. And then we set up the other two vertex color channels for the curvature and the ambient occlusion to help us do other kind of shader manipulations in Unreal if we wanted to. We can remove small parts that have somehow ended up separated from the main mesh. and then we set some attributes for Unreal. So these are the attributes in Unreal that are responsible, or rather, these are the attributes for the Houdini engine that allows it to allows Unreal to understand the asset, where should it go in the outliner, where should it go in the bake folder, as well as which material should be assigned and what its name should be once you've baked it. And that really brings us to the end of this asset. So yeah, we're going to have a look at setting up a similar graph now, and we'll go through it step by step over the subsequent video tutorials.